Okay, you're back to 3.1 and 3.2. So these are the answers to our green sheets. Sorry, there was I think it was 5 and 25 here. Okay, now we're going to move on. Recognize and evaluate logarithmic functions with base A. This goes back to the little rhyme Mrs. Gallatin taught you. The base to the outie equals the innie. So in this case, the base is 5. Base to the outie. The outie is -2 equals the innie. The innie is 1 over 25. So the base to the outie equals the innie. And we know this is true, right? Because 5 to the -2 is the same as saying 1 over 5 squared, which is 1 over 25. So we know this is true. All right, on our next one, it's doing it in reverse. This is the base of an exponent. So this is our base. So we have log base 2. To the base to the outie. Well, that means that my -5 is my outie. Because it's the base to the outie. So that's my -5. So, oh dear. There we are. So that means this equals -5. Equals what goes inside. So my equals is the 1 over 32. So that makes my innie 1 over 32. So 1 over 32 goes inside. All right, so that's forwards and backwards. Base to the outie equals the innie. Use a calculator to evaluate f of x equals log x at the given value of x. So all we have to do is put into our calculator the log of 1 divide 50. And that is going to be our answer. And I get -1.699. The 8 rounds up to a 9. All right, now we're going to simplify. This uses our base, okay? So this is our... All right. One of the easiest ways to look at this is to rewrite this. I'm telling you that those will cross off, leaving me a 7. But let's do it so you can see why that is. Remember the rhyme we just did. The base to the outie equals the innie. Okay, so I'm going to take this off so we can see it better. All right, so the base to the outie. So the base is 9. So we're saying log base 9. The base to the outie. Okay, so base to the, so that's my to the, equals the innie. So this is my innie. Log base 9 of 7 is equal to, what a shock, log base, I'm sorry, I said log base, sorry, I said that all wrong. Log base 9 of 7 is equal to log base 9 of 7. This is such a surprise. Okay, base to the outie equals innie. That's all this is doing. Okay. Oops, sorry. We didn't finish the last bit. Now down here, we can use our one-to-one property, which says if these are the same base, which in this case, since they're common logs, they are, I can take the two insides and put them equal to each other. So 5x plus 8 equals 19. Subtract the 8, divide by the 5. So that's my x. Okay, that's all there is to it. Set it up for the one-to-one property. Makes it really easy. All right, so now if I graph the log 3 of x, sorry about that. If I graph log 3 of x in my calculator, and I graph negative log 3 of negative x. Negative log 3 of negative x is exactly what you see on here right now. Now I'm going to extend this axis out a bit just so you can see it better. Our parent function, log base 3 of x, is, I'm going to change color so you can see it, simply comes this way. Okay, so what you may not see is our first subtraction. I'm changing colors. So we'll take that negative. What that does is rotate it around the x-axis, turning it into this blue line. Okay? Then we have this negative, flips it around the x-axis, turning it into the line they gave us. So this is actually two rotations. This is a rotation in the x and a rotation in the y. So when we look at the words we're given, we see that there's only one that specifies rotation in the x and the y. This one says shifts. There are no shifts. No shifts. No shifts. This rotation is only talking about the y-axis, so there's only one answer, and it's our very first one. Now when we look at the domain, the thing to remember always is I cannot have, see, this happens when I put my wrist down on the, my hand down on the screen when I'm writing. I apologize. So what we know is what's inside the log must be greater than or equal to 0. So we have x over 4 is greater than or equal to 0. If I multiply through by 4, the 0 is going to stay the same, and my 4 goes away in the numerator, in the denominator, sorry. Right? If I multiply both of these by 4, I get x is greater than or equal to 0. So my domain has to start at 0 and go to infinity. There's no negative portion because it's greater than or equal to. Oh, I apologize. It has to be just greater than. I misspoke. Cannot be equal to either. Now the reason for this, try to get rid of, oh, I did it. So that's why it's a parenthesis, not a bracket. Now the reason for this is that no matter how many times, if you think about this, what I'm trying to say with a logarithm is, sorry, I keep changing colors and stuff. Log base, we'll just do base 2, just for fun, of x. What that's saying is that 2 to the y is equal to x. Well, no matter how many times I multiply 2 to itself, I'm never going to get a negative number. Never, ever, 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 ever in a million years am I going to get a negative number. I cannot multiply 2 positives and get a negative. It's just never going to happen. So I will never get a negative. So what's inside my logarithm can never, ever, 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 ever be negative. It cannot be equal to 0 either. I cannot multiply a number times itself and get 0. The only way I can do that is if I multiply 0 in there somewhere. And this is not asking for any other numbers besides the base. So it can't be 0 either. So it must be greater than or equal to 0. So set the insides equal greater than 0. Insides greater than 0, solve. That gives you your domain. Now the x-intercept, this happens when I have a y of 0. So we have 0 equals log of x over 4. So using my base to the outie equals the ne, I have 10, oh dear. I have 10 to the outie equals my ne. What's 10 to the 0? What's 20 to the 0? What's 50 to the 0? What's 563 to the 0? Remember, anything to the 0 power is 1. So no matter what, this is now 1. So I have 1 equals x over 4. If I multiply both sides by 4, I'm going to get x equals 4. So 4 is my x-intercept. All right, now find the vertical asymptote. The vertical asymptote is based on the domain. So what I'm saying, that domain says x cannot equal 0. So my asymptote is x equals 0. Okay, moving on. All right, and I kept a bunch of my. That's kind of weird. Let's do something. Erase all constant. No, it still didn't erase. Now it doesn't know I've got any. Let's try erasing all this ink. Interesting, interesting. Okay, well, there we go. I'm gonna get rid of that, so maybe. There we go. Yay. Okay, that was interesting. So this is just base to the outie equals the innie. Remember, natural log of 4 is the same thing as saying log base e of 4. Now we can just do the base to the outie equals the innie. The base to the outie equals the innie. So our answer is the fourth one down. Alright, I'll go ahead and show you your in-class practice, the answers, and then I want you to go do it. Make sure you show all your work. Alright.